Alright there, Ramblers, let's get rambling on this last one. So I'm hoping you guys aren't hating me too much right now, because I know a lot of you guys worked very hard on Level 3 trying to prove why this statement is true, only to kind of be left in the cold when you realize when revealed in class that it is impossible to prove, at least at this point. We need some more information, we need some better techniques, or at least some better knowledge. And maybe a new way to kind of consider or view proofs. So take this triangle, and in this video, let's take an opportunity to kind of explain why it's impossible, or why we can't really carry it over with the current proof techniques or methodologies that we have. So we just have this triangle. I'm just going to call it ABC. There's nothing special about this triangle at all. We don't know if isosceles or right, or scaling, or acute, or obtuse, or nothing. It just exists. And then we're asked to make a construction on this. We're to pick the midpoints. Let's go daisies. So we're trying midpoints of two sides, and I'll just pick the midpoint of AB and then the midpoint over here of BC and connect them using a segment. So we have this segment, which I'll draw in blue, that connects these two midpoints, and I kind of missed on that one, no big deal. And what this theorem is saying is that if you do this construction as prescribed, then the DE line has a relationship with the remaining side AC. And that relationship, which we can at this point trust to be true, even though we can't prove it yet, is that DE is precisely 1/2 of AC. And also that these two sides are parallel, which will give us a whole bunch of information about angles and a whole bunch of wonderful stuff. But here's the problem. We can't prove this. Like, how in the world do we prove this? I mean, consider that for a minute. Like, I know that these are midpoints, so I guess I do know these sides are congruent, and these pair of sides are congruent. But what else do I know? How else am I going to prove that we have angles or anything that I'm not handed in the givens of the statement? Now, the most clever thing I saw someone do is to impose a construction on here. And several people did it, but a couple people were working on this really, really carefully. Here's the construction I saw. If you take AC and find its midpoint, boom, stick a midpoint right there. And then connect using a line segment, let's go purple, D to this new line segment. What you've created for yourself, let's call it F, is some potentially congruent triangles. Let me kind of highlight what I mean. If I look at this triangle and I look at this triangle, and if I can somehow prove that they are congruent, I'm in business. And the reason why I'm in business is because if these are going to be congruent, then these angles should be. And if these angles are congruent, my lines are parallel. Here's the problem, though. I can't prove these triangles are congruent. Reverse, 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 reverse. How in the world can I prove they're congruent? I see that there's one matching side, but how can I prove that BE is congruent to DF? Or any of the other angles, like these, there's no way I can link these two angles together, or these two angles together, or get these last sides. I just don't have enough information to do it. So we puzzle a little bit about what are alternative ways to show things are parallel. I don't know at this point. Like, this is just too much really kind of going on to show that these are going to be parallel. I just don't have the information, and I just don't have kind of the technique. So this one we kind of have to give up on. Like, at this point, we got to leave this one as unprovable for now. Dun dun dun, which means that we're going to have to actually deal with this later once we kind of have some techniques next week. So DE being parallel to AC and DE being half of AC is going to have to wait to be proven. Now, that doesn't mean we can't use this information. I'm going to be asking you to use this information moving forward, especially on Friday. It's just we can't prove it yet. Now, this should not be a big deal. I know some people are saying, well, Mr. Collins, you said we had to prove everything. But keep in mind that we use theorems all the time that we haven't proven. In fact, I had you guys use triangle sum theorem at the beginning of the year without it being proven yet, and this is going to have to fall in that case. So we're going to prove this later. We can't prove it right now. We just simply don't have the information here. We don't have enough about side lengths or angles to prove parallel lines. And if we can't prove parallel lines, guys, then what is the point of proving this relationship of length? I mean, again, this is kind of a preview. We will be dealing with this in the near future. So again, please don't be too angry. Again, if you have questions, post them at Moto, ask them in class. Let's keep the conversation going. Thank you guys so much for watching this. You guys have a great day.